At Northrop Grumman, innovation isn't just an idea. It's a way of life. The value of performance. Northrop Grumman.
I've written about 300 books, which is impossible to talk about, because if everybody raised their hand here, I'd have a different book for every hand that's up. In fact, I took a picture of a shelf of my books the other day, and I can see books on sharks and lightning and hurricanes and earthquakes and weather and oceans and all these other books, and I can't talk about any of them. And the reason I can't talk about any of them is just too many. Imagine if you had 300 kids, or imagine if you had 300 brothers and sisters, and you're going on a trip in a family car, and I don't care how big the car is, you keep squeezing them in the front, they keep popping out the back, and that's the way I feel about my books. And the first book I'm going to talk about, I can't show it to you. And the reason I can't show it to you is because there was only one copy, and I lost it a long time ago. Here it is when I wrote my first book. You know, I was in second grade when I wrote my first book. It was a book called Space Monsters. And that's the way authors begin. If you want to become a ball player, you don't wait till you're 21 years old before you pick up a ball for the first time in your life and start playing ball. You start when you're young. If you want to become a musician, you start playing an instrument when you're young. If you want to become a writer, you begin writing when you're young. How many of the kids here have ever written a report or a story? Raise your hand. You're authors. Put your hands down. The only difference between you and me is if you keep on writing, somebody may take what you've written and publish it, and then you become what's called a published author. Well, I did that. Here it is. When I was grown up, I remember this book I wrote when I was a kid, and I wrote it again. It's called Space Monsters from Movie, TV, and Books. It's a kind of a history of science fiction, which I loved, and that's really the same book that I did when I was in second grade. In fact, a lot of the books that I do now, I do because of what I remember when I was a kid. I was mostly interested in space monsters when I was in second grade, but by third grade, I became mostly interested in the other half of that title, Space Monsters. And what interested me the most about space monsters was, where was I located in space? How did I fit into space? And by sheer coincidence, my third grade teacher was teaching something which had nothing to do with space, but it gave me a perfect opportunity to locate myself in space. All she was doing was teaching us how to write your return address on a letter. And she said, if you want to write your return address, you put your name, the street you live on, the city and the state and the zip code. And everybody was doing that except for me. Because underneath what every other kid in the class was doing, I wrote down the name of the planet that I lived on. So raise your hand and tell me, what's the name of the planet that most of us here live on? Yes. Not you. You. We'll get to Mars in a little while. Go ahead. What's our planet? Earth. So underneath my address, I put down Earth. Put your hand down. But I wasn't finished, because underneath planet Earth, I put down the name of the whole group of planets that Earth belongs to. Not each individual planet, but what do we call all of the planets together? Yeah. Much smaller than the Milky Way. Shh. Raise your hand. Yes. The solar system. So underneath planet Earth, I put our solar system, and I wasn't finished, because the solar system is one small group of planets circling one small to medium-sized star we call the sun. What's the enormous group of stars that we're part of? Yes. Milky Way galaxy. So underneath solar system, I wrote Milky Way galaxy, and I still wasn't finished, because the Milky Way galaxy is only one galaxy in space. And what do we call all of the galaxies and all of the stars? Yeah, the universe. And that's what I consider a complete return address. And as soon as I did that, every kid in the class copied me. And I remember that address when I grew up, and I wrote a book. The book is called The Long View into Space. It starts on planet Earth, it goes to the ends of the universe, and I'll show you what I put on the last page of my book, the address that I had when I was a kid. Name, street, the city or the town, the state, the zip code, the country, planet Earth, system solar, galaxy Milky Way, the universe. But kids are much smarter than I am these days. And I got a letter from a kid in a school in Ohio the other day, a school I was going to go visit. He went all the way down to universe, and the post office delivered it the next day. They probably thought it was very important. But then the kid did something I hadn't even thought of. So I just put down a question mark. I don't have that in the book. So raise your hand if you can think of what brilliant zip code this kid from Ohio did for the universe. What would be a brilliant zip code? Yes.
3.14.
That's your zip code, but I don't think that's the universe. What's a really good zip code that means everything? Yes? Exactly right. He put down the symbol for infinity, which looks like a kind of a sideways 8. It's really a Greek letter. It stands for infinity. So when you go home tonight and you put down your address, and I assume you will all put down your address down to the universe, put down the symbol for infinity as the perfect zip code. And I'm going to take you on a trip right now from Earth to infinity. And I'm going to use my books as a kind of a guide. Here's my book called Earth, Our Planet in Space. And if you take a look at that cover, you see that somebody made a mistake. The mistake is we never should have called our planet Planet Earth. We should have called our planet Planet Water. What's all the white stuff that covers so much of this planet?
Clouds.
Clouds, which are made of water. What's all the blue stuff that covers so much of the planet? Oceans, which are made of water. So where's Earth? Well, there's a little piece in the middle, the brown piece in the middle. There's a little piece on top. We are the only planet that has liquid water on the surface. And it's a lucky thing for us that we do, because without liquid water, none of us would be here. Life, as we know it, in order to exist, needs liquid water. Without liquid water, we would not be here. Now, I've written lots of books about Earth, but if we're going to get to the ends of infinity, we have to really start going. So somebody raise a hand and tell me, what's the closest thing to us in space by far? Astronomers like to say it's within spitting distance. The moon, right on top of us. There it is. It's so close that astronomers think it's really not even worth going into space practically. But nothing in space is that close. And if you read my book on the moon, it tells you how many miles it is, but it's just a big number. And the truth is that one big number is like another big number. You can't tell the difference between something if it's 240,000 miles, or 240 million miles, or 240 billion miles, and I could keep on going until the numbers become, you never even heard of the numbers before. So if you want to see how far away the moon is, take a look at this ball. I'll show you how far away the moon is the ball. If you watch the ball, and you'll never forget it. Watch the ball, because the truth is, I don't care how carefully you watch it. If I drop it, it falls so quickly, it looks like a blur. Look, if you think that's fast, listen to this. In the time it takes this ball to fall from my hand to the floor, in that amount of time, the spaceship, which we sent to go to the moon, can go 7 miles. That spaceship is so quick, it could get from here to the airport in 2 seconds. It took me 2 3/4 hours to come here from New York City by train yesterday. That spaceship could make that trip in about 10 seconds. That spaceship is so fast. And yet when we sent that spaceship to go to the moon, it still took that spaceship 2.5 days to get to the moon. Now the moon is practically right on top of us in space. And a spaceship going just that quickly still took 2.5 days to get to the moon. Raise your hand if you know the name of the guy who first left footprints on the surface of the moon. Neil Armstrong. He left these footprints about 30 years ago. You wouldn't expect footprints to last for 30 years or longer. No wind, no water, no rain. Those footprints will last for 1 million years or longer, unless there's a moonquake. And there are. Just the way there are earthquakes on Earth, there are moonquakes on the moon. That might disturb the footprints. Or unless a meteorite comes crashing into the surface of the moon and hits the footprints, that might disturb the footprints. Or unless some idiot lands there with a spaceship and runs out with a broom and neatens up the moon a little bit. If that doesn't happen, those footprints will still be there in 1,000,000 years. Neil Armstrong is bouncing around like a bunny rabbit. How come that's possible? You would expect with this big, heavy spacesuit, he could barely move. Not nearly as much gravity. If you weigh 100 pounds on Earth, on the moon you'd weigh 16 pounds, which means a lot of you could jump as high as the ceiling, which is really great if you're playing basketball. You go up for a rebound, and on the way down, you dunk it. The big problem is when you land on the surface of the moon, you would land with exactly the same amount of force that you do on Earth. Imagine falling from the height of the ceiling to the surface of the moon, and you can imagine, and you can hear the astronauts were being continually warned by the technicians back on Earth, don't jump, don't jump. They were terrified that these astronauts, because it's so easy to jump, would come down and crash and break a leg or rip their spacesuit, in which case they were dead. There was no backup spaceship. They either got back by themselves or they didn't get back to Earth. And that's why they're heroes. They knew that when they went to the moon, there was no chance for them to come back to Earth except if they got themselves back to Earth. When I was a kid, my favorite planet was Mars. My first book was Space Monsters. My favorite planet was Mars because I thought aliens came from Mars. And I wasn't the only one. A lot of scientists thought that space monsters came from Mars as well. And the reason they thought so is because of this drawing made by a very great astronomer about 100 years ago. Now, why is it a drawing and not a photograph? Because at that time, you couldn't take a very clear photograph of Mars through a big telescope. You had to take what's called a time exposure. You stuck your camera at the end of a telescope, you opened it up, and you let it stay open for about 2.5 hours before you got enough light to get a photograph. And in that time, something was happening. You're trying to photograph Mars through Earth's atmosphere. And Earth's atmosphere is full of dust and water, and it's moving. It's like trying to take a picture through a dirty window that somebody is shaking. You get a blurry picture. But this astronomer never bothered to take a photograph. He just looked, and he looked night after night, hour after hour, and every once in a while, when the atmosphere stopped shaking, he got a crystal clear look at the planet Mars, and he began to think he saw something. What he thought he saw was straight lines crisscrossing the planet. Now, there are no straight lines in nature. If these were rivers, they would be wiggly. So he looked at what he thought he saw, and he decided that these straight lines were gigantic Martian canals. If canals are man-made, and if there are canals on Mars, what does that mean? Aliens who build canals. The problem was, not everybody saw these. I mean, you can't take a photograph and you can have your friend looking and you say, Joe, look, canals. And Joe comes over and looks through your telescope, says, I don't see anything. You say, idiot, look again. He says, I still don't see anything. You could hit him, but that doesn't prove anything. The only way to find out would be to go to Mars and find out, and we did. We sent a number of spaceships to Mars, and Mars is one of the closest planets to Earth. And remember our spaceship that took 2.5 days to get to the moon? When we sent that spaceship to go to Mars, it would take that spaceship 1 year. And if it takes a year to go there, it's going to take a year to get back. And we didn't know if anybody could live that long in space. They would need all the things that people need in order to live. Food, and water, and oxygen, and video games, and everything else you need in order to live. So we didn't send anybody on board. We sent a spaceship loaded with instruments, and when they got close enough to Mars, they could see that Mars had red sand and soil, but no plants. We've never found a plant growing on Mars. No little animal wiggling by. We've never seen an animal on Mars. No Martians coming over to say howdy. We've never made a Martian on Mars. That still didn't mean there's no life. Maybe the life was invisible. Not like the invisible man. Maybe it was invisible because it was too tiny to see. Maybe it was invisible because it was hidden in the soil, but we had a way of finding out. So on orders from Earth, the Martian lander stretched out a robot arm as far as it could reach, dipped down into the Martian soil, took a handful of Martian soil and brought it back into the spaceship and did 3 different experiments to see if there were any chemicals in the soil that could only come to from living things. And every experiment came back negative, which is really too bad. Because of all the planets in the solar system, other than Earth, the only other planet which would have any possibility of life was Mars. The other planets are too weirdly different. The biggest planet in the solar system, Jupiter, which is the next planet after Mars, is a giant gaseous planet. You see that big red eye in Jupiter? That big red eye is so big, it's a giant storm. You see my little ball? Compared to that storm, that's the size of planet Earth. That single storm could swallow up 2 or 3 entire planet Earths. In fact, if you could put Earths inside Jupiter, like pennies in a piggy bank, you could put 1,300 planet Earths into Jupiter. And Jupiter's a weird planet. Even if you tried to land on Jupiter with a spaceship, it would be like trying to land on a cloud with an airplane. Your spaceship would just sink right down through the surface of Jupiter because it's just made of clouds. It would go tens of thousands of miles below the surface until it came to the solid inner core, and by then your spaceship would be crushed because Jupiter is such an enormous planet that it has an enormous gravitational pull. If you weigh 100 pounds on Earth and 26 pounds on the moon, 16 pounds on the moon, you would weigh 265 pounds on Jupiter. And even if the spaceship could land, it could never take off again. The most beautiful planet in the solar system is Saturn, with its gorgeous rings, which were discovered over 400 years ago, by the greatest scientist of that time, Galileo. He trained his little 10-power telescope at the planet Saturn, and he saw what he thought were ears. He wrote in his book, "It looks as if the planet Saturn has ears." Now, he knew they weren't ears. He didn't know what they were. They were bulges on either side. 100 years after Galileo died, when we got good telescopes, we could see that these were really rings. And the truth is, they ain't no rings at all. These rings are not really rings. They're made of pieces of ice, chunks about as big as your fingernails, some is about as big as a house. And they're spinning around Saturn like thousands of tiny moons. And from far away, we think that these look like rings. As big as Saturn and Jupiter are, and they're both enormous, they're tiny compared to the sun. When I was a kid, I couldn't believe the size of the sun. And in my book on the sun, you can see how big it is in miles, but let me show you how big it is. Take a look at my little ball. I'm not going to drop it. Just look. Imagine that this is planet Earth. If this ball is planet Earth on the same scale, the sun is about the size of this room. Look around the room and look at planet Earth. And if we could magically put Earths inside the sun, we could put 1,300,000 planet Earths into the sun. And if we put all the planets and stuck them together, Jupiter and Saturn and Uranus and Neptune, and all of them stuck them together, the sun is still 600 times bigger than all the planets stuck together. And as big as the sun is only a small to medium-sized star. Every star we see in the night sky is a sun. And some of them are a lot bigger than our sun. There are some stars that are as big as Washington, D.C. And there are so many stars, and why do they look like little dots of light? Because they're so far away. Remember our spaceship that took a year to get to Mars? If we sent that same speeding spaceship to the closest star beside the sun, it would take that spaceship 70,000 years to get to the closest star. So we're not going to visit the stars. Nobody has the time to visit the stars. And there are so many stars we could visit. In my book on the Milky Way galaxy, you can see how many stars we could visit. But it's just a number. So imagine this. Imagine if we took this entire room and filled it with sand. Wouldn't that be fun? And imagine if we took every room in this building and filled it with sand, and every hall and filled it with sand. And then imagine if we sat down and counted every single grain of sand in the entire building. There are more stars in the Milky Way than there would be grains of sand in this entire building. Imagine. And that's just the Milky Way galaxy. In the universe, there are millions and millions of other galaxies, all with the same number or more of stars. So how many stars are there in the universe? Imagine this. If we sat down and counted every single grain of sand on the entire planet Earth, there are more stars in the universe than there are grains of sand on the entire Earth. I said I would take you to infinity, so let's go. Let's get to the ends of the universe. What is there, a brick wall with a little sign on it? This is the end of the universe, don't look anymore. Is it written in English? I doubt it. Einstein, the greatest scientist of the 20th century, said there really is no end to the universe. It's all enclosed in itself. If you traveled at the speed of light in what you thought is a straight line, what really is happening is that you're traveling in a gigantic circle, and after 13.5 billion years, you would come back to where you started from. It's curved in on itself. If you don't understand that, fine, nobody does, but this is one of the constructs of that. I've tried to take you as quickly as I could through the universe, but I've written books about lots of things, and I'm in constant communication with kids across the country about my books. This is my website, SeymourSimon.com. You can always go there, send me a note. I'll try to answer whatever questions you have. I'll try to keep up the correspondence about you exploring science, about reading my books or other people's books. We also have a digital library called Star War Kids, where many of my books are involved there.